Hello, I'm Kabuki, and it's great to be back at SEMA for this workshop. Today we will focus on shaping sound using frequency modulation techniques. FM synthesis is often considered to be a complex subject, but in this workshop we will go through the basic and you realize it's nothing to be afraid of. Almost everybody is aware of how subtractive synthesis works. You take a sound that is rich in overtones and remove elements of the spectrum using a filter. FM synthesis works just the other way around. You take a simple sound source as a carrier and then use another sound to modulate the frequency to create more complex timbres. Using this method, you're able to generate sounds that are almost impossible to create with any other synthesis technique. Furthermore, automating parameters in FM synthesis can seamlessly change the character of a sound from tonal to out of this world and back again. I will use Native Instruments FM8 as an example, but almost every workstation comes with their own FM synthesizer. Ableton has the operator, Logic Pro comes with the RetroSynth, and FL Studio has Citrus. The FM matrix shows the signal flow of the synthesizer. Oscillators are also called operators in FM synthesis, and in FM8 we can use a total of 6 operators. We are hearing operator F, which is sent to the master at 100% volume setting. The waveform is set to a sine wave, creating only the fundamental of the note with no overtones. Shaping the envelope of an operator changes the amplitude over time, so that sounds can fade in or out depending on the attack and release settings. Ratio is an important parameter in FM synthesis. It determines the pitch offset of the operator. A ratio of 1:1 would give us the exact same pitch that we play on the keyboard, while a ratio of 2:1 would double the frequency, pitching the operator 1 octave up. Next, we activate operator E, which is not yet routed to the master. Routing it to the master would allow us to mix the two operators, but that would result in additive synthesis, not FM. Instead, we remove the routing to the master and use the signal of operator E to modulate the frequency of operator F. Setting the frequency of oscillator E to below 20 Hz will result in a slow change of pitch of oscillator F. The musical term for this is vibrato. Once we go above a certain frequency, we create a metallic timbre. This is FM. But in order to have more control over the end result, we should set the frequency using the ratio parameter. The basic rule is simple. Setting the ratio to multiples of 0.25 will create tonal sounds, while values in between will generate more atonal timbres. Changing the amplitude of operator E affects the timbre of operator F accordingly. We can also do this over time using the amplitude envelope. The next level of complexity is to modulate the frequency of operator E by means of operator D. Depending on how we set up the individual envelopes, we are able to animate different sections of the sound. See, it wasn't so difficult after all. Now you're able to harness the power of FM synthesis to supercharge your sound design process. And remember, practice makes perfect, and every journey begins with the first step. Give it your best shot.